Here we want to find any intercepts of the function y equals x times the square root of 81 minus x squared. So this word intercepts means any point that contains a zero. So any ordered pair of this function such that either x equals 0 or y equals 0 or both. So let's start with the x-intercepts. And if you think about any point on the x, or any point in the Cartesian plane that's on the x-axis, any point on the x-axis will take the form x comma 0. So x-intercepts occur when the y value is equal to 0. So let's go ahead and solve for the x-intercepts. So we'll set this function equal to 0, 81 minus x squared. And so we could factor the 81 minus x squared. That looks like a difference of squares. So we could say this is x times the square root of 9 minus x times 9 plus x. Okay, and if you want, and this isn't entirely necessary, but we could go one step further, and the square root of a product is equal to the product of the square roots. So x times the square root of 9 minus x times the square root of 9 plus x. And now the zero factor theorem states that if you have the product of things equaling 0, then any factor in that product is equal. For a solution is such that any factor in that product is equal to 0. So either x equals 0, the square root of 9 minus x equals 0, or the square root of 9 plus x equals 0. So we have three solutions. X equals 0. In this case, 9 minus x is 0 when x is equal to 9. And in this last one, 9 plus x is equal to 0 when x is equal to negative 9. So those are our three x-intercepts. Well, actually, an intercept is a point that contains a 0. So the three x-intercepts would be 0, comma, not 0, comma, negative 9, comma 0 would be 1, 0, comma 0 would be another, and finally 9, comma 0 would be a third. So those are the three x-intercepts, and 0, 0 is on the y-axis, so that's also the y-intercept. So we have 3 points, although it's 3 x-intercepts and 1 y-intercept. Okay, that does it for this problem. I hope it was helpful.